This is the fourth video for Chapter 6 on trigonometry. In this video we're going to look at two new trig identities that come from the identities you learned in Lower 6. So in Lower 6 you learned that sine squared x plus cos squared x is identical to 1. If we take that trig identity, sine squared x plus cos squared x is identical to 1, and we divide both sides by sine squared x, this is what we get. We get sine squared x over sine squared x plus cos squared x over sine squared x is identical to 1 over sine squared x. And of course, sine squared x over sine squared x is 1. Cos squared x over sine squared x is cot squared x, and 1 over sine squared x is cosec squared x. Another one, again, if we start with sine squared x plus cos squared x is identical to 1, and this time we divide both sides by cos squared x, we get sine squared x over cos squared x plus cos squared x over cos squared x is identical to 1 over cos squared x. And of course, sine squared x over cos squared x is tan squared x plus cos squared x over cos squared x is 1, and 1 over cos squared x is sec squared x. So that is how we get our two new identities. So the two new identities are 1 plus tan squared x equals sec squared x, and 1 plus cot squared x equals cosec squared x. Now, as before, we can rewrite these identities, so we can rearrange them. Okay, so the first one, you could rewrite it as sec squared x minus tan squared x is identical to 1, or you could have, if you wanted, tan squared x is identical to sec squared x minus 1. Okay, so you can see you can get the sec squared x and tan squared x on their own. The bottom one, 1 plus cot squared x is identical to cosec squared x. You could have cosec squared x minus 1 is identical to cot squared x, or you could have cot, that out, cot squared x is identical to cosec squared x minus 1. So once you've learned those identities, you can rearrange those. So we're going to look at how we can use those, first of all, when we're simplifying. So the first one is we want to simplify sin x over cos x plus cos x over sin x. Okay, so in this one, sin x over cos x, you can see we've got a fraction, so our common denominator will be cos x sin x, and in the numerator we're going to have sin squared x plus cos squared x. Of course, from last year, sin squared x plus cos squared x is 1, and then we get cos x times sin x in the denominator, and then we're going to split that up, so we get 1 over cos x times 1 over sin x, and of course 1 over cos x is sec x, and 1 over sin x is cosec x. So that's was simplifying it. Now the next one is 1 over cos x times the square root of 1 plus cot squared x. So on the top we're going to get 1. In the denominator we're going to replace the 1 plus cot squared x by cosec squared x, because that's its replacement. And then of course when you square root a square they cancel each other out. So in the denominator now you've got cos x, cosec x. Of course that's the same as 1 over cos x times sin x, because of course you've got 1 over cosec x is 1 over sin x. Goes in, of course, therefore cos over sin is cot x, which of course 1 over cot will be tan x. Now we could have done that here, okay, because in this step here, because you know that is 1 over 1 over sin x, could have written that as 1 over cos x times sin x, which of course is tan x, so we could have done it there. Right, let's have a look at how we can use this in a question. So we've got, given that a equals 4 sec x, b equals cos x, and c equals cot x, first of all we want to express b in terms of a. Okay, so I'm going to start with a. Okay, start with a. So we've got a equals 4 over cos x, because of course sec x is 1 over cos x, and we know that b is cos x, therefore a must be 4 over b, and we want b in terms of a, therefore we can cross multiply, so we get b is 4 over a. Now if you look at b, it then says show that c squared equals 16 over a squared minus 16. So we know that c equals cot x, therefore c squared must be cot squared x. Okay, we know that cot squared is 1 over tan squared x, and that tan squared is sec squared x minus 1. Now we need to introduce into it cos. Now we know that we were told right up at the top that a was 4 sec x, therefore a squared must be 16 sec squared x, therefore from that sec squared x must be a squared over 16. So I'm going to put that into the line we've got here, so I'm going to substitute that in, so we end up with c squared equals 1 over a squared over 16 minus 1. Now to get what we want, we're just going to multiply top and bottom by 16. Remember, multiplying by 16 over 16 is the same as multiplying by 1. So we're going to get c squared equals 16. And of course, a squared over 16 times by 16 is a squared, and negative 1 times 16 is negative 16, and we've got what we wanted. Now, we can also use these identities when we are solving equations. So the first one we're going to look at is sec squared x plus tan x equals 3. And the first thing we need to look at is whether we're working in radians or degrees. You can see that we're working in radians. So when we solve equations, remember, most of the time we need the same trig function. So we've got sec squared and we've got tan. We usually change the squared trig function. So we've got sec squared. So we know we can replace sec squared by 1 plus tan squared. Then x plus tan x equals 3. If we rearrange that, get tan squared x plus tan x minus 2 equals 0. Then we can use our calculator to solve that for us. And when we solve it, we get that tan x equals negative 2, or tan x equals 1. Again, x must be the inverse tan negative 2, or x is the inverse tan of 1. When we get our calculator, remember we need to be working in radians. X comes out as negative 1.11 to 2 decimal places. And of course, because it's tan, just add on pi, so we get 2.03. And of course, other one, x equals pi over 4. If you add on pi, it goes more than the range, because our range of values is negative pi to pi. So if you take off pi from pi over 4, you also get minus 3 pi over 4. So that's the first one. Notice I've not used a cast diagram because it's a tan one. Next one is 2 cot squared x plus cosec x plus 1 equals 0. And this time I'm working in degrees. So I need to make sure my calculator is working in degrees for me. And if you have a little look, you can see it's the cot squared x that I want to swap. I want to keep the cosec. So, and of course, cot squared x is cosec squared x minus 1. So again, if I swap in solver, cosec squared minus 1 plus cot cosec x plus 1 equals 0. Multiply that out, get 2 cosec squared x minus 2 plus cosec x plus 1 equals 0. So 2 cosec squared x plus cosec x minus 1 equals 0. And again, get your calculator to solve that for you, to tell you what your values of cosec are. You get that cosec x equals a half, or cosec x equals negative 1. Therefore, remember, we then do the reciprocal. So sine x equals 2, or sine x equals negative 1, because the reciprocal of negative 1 is negative 1. Remember that sine x only has ratios between negative 1 and 1, so this one has no real solutions. So that's why we stop with that one. And of course, you should know without a cast diagram that sine x equals negative 1 when x equals negative 90. And that's the only value within the range that we want. Okay. I'm going to let you have a little go at the third one yourself. Okay. But the one that you are going to change is the tan squared. You change that for sec squared minus 1. Remember, you're working in degrees, and you need, again, to get only 2 solutions. If you write your solutions down to 1 decimal place, that's usually quite useful. Now, the other thing that we can use these new identities for is proof questions. And often with proof questions, it's a good idea to start with one side, usually the most complicated side, and make it look like the other side. So this first question, it said we need to show that tan squared x minus cot squared x is identical to sec x minus cosec x multiplied by sec x plus cosec x. So I'm going to start with the right hand side, and the usual way we do with this is we write the right hand side equals, and that's sec x minus cosec x multiplied by sec x plus cosec x. Now what you should notice there is that is a conjugate pair of brackets. So when you multiply that out, you're going to get sec squared x minus cosec squared x. Now you can do that, you notice that you can multiply that out straight away. Right, now the sec squared x we can replace by 1 plus tan squared x, or tan squared x plus 1, and the cosec squared x is 1 plus cot squared x. If you then expand that, you get 1 plus tan squared x minus 1 minus cot squared x. And of course the ones cancel each other out, and you get tan squared x minus cot squared x, which of course equals the left hand side. And that's what we're trying to do when we do a proof. Okay, we'll have a little look at number 2. I'm going to leave number 2 for you to do yourself. Okay, and if it was me, I would start with the right hand side, because in the right hand side you can already see tan squared, and on the left hand we just want tan squared and a numerical value. So I would start with the right hand side. So we'll have a look at number 3. Number 3 says we need to show that or prove that sine squared x multiplied by 1 plus sec squared x is identical to sec squared x minus cos squared x. So I'm going to start with the left hand side. There's no rule, but we usually start with the side that's more complex. So I'm starting with the left hand side. And as you can see, in the left hand side I've got sec squared x, so I just need to replace the sine squared x. And if you remember, sine squared x is 1 minus cos squared x. And that's multiplied by 1 plus sec squared x. Now if I multiply that out, I get 1 minus cos squared x plus sec squared x minus cos squared x times sec squared x. Okay, now if you look at that last term, you should notice that that cancels itself out, and I'll show you why. We've got cos squared x, and of course sec squared x is 1 over cos squared x, so they cancel to give you 1 minus cos squared x plus sec squared x minus 1, and of course we write it in the form so the ones cancel each other out, and you end up with sec squared x minus cos squared x, which of course equals the right hand side. Okay, let's have a little look at the fourth one then. And the fourth one is saying to us it's cosec x minus sine x is identical to cos x cot x. So again, I'm going to start with the left hand side. Okay, which is cosec x minus sine x. I'm going to write those in their other form, and it's always a good idea to keep an eye on what you're heading for. So cosec is 1 over sine x minus, and it's sine x over 1. Now you can see we've now got some fractions, So I'm going to write those. Common denominator, of course, is sine x. So I'm going to get 1 minus sine squared x. And of course, 1 minus sine squared x is cos squared x over sine x. I'm then going to split that down. So cos squared x, of course, is cos x times cos x. So this is cos x times cos x over sine x, which of course is cos x cot x, which is of course the right hand side. So again, we've done our proof. Right, just got one more to have a little go at. So the last one is cos x plus sec x all squared is identical to tan squared x plus cos squared x plus 3. So I'm going to start again with the left hand side. And the left hand side is cos x plus sec x squared. Now again, you should be able to tell me what that is. So that's cos squared x plus sec squared x plus 2 cos x sec x. Okay, and again, if you look at what we're heading for cos squared. Well, we've got cos squared and we need a tan squared. So I'm going to leave the cos squared x because I need that in the final answer. I'm going to swap the sec squared x for 1 plus tan squared x. And of course, the last term you've got 2 cos x, and sec x of course is 1 over cos x. So that gives you 2. So you've got cos squared x plus 1 plus tan squared x plus 2, which of course is tan squared x plus cos squared x plus 3, which equals the right hand side. So we've done our proof. Now when you're doing these, it's a good idea first of all to write your identities at the side, and then always be mindful about what you are trying to prove. And that is the end of this video for trig identity.